Hi everybody, this is Dino Chris from Prehistoric Facts. This is an extra episode. Again, this would actually be controversial theories or discoveries in paleontology. And I did a video before. It was basically about the Bone Wars. Check it out, and you can actually come and actually watch this episode next. But anyway, let's actually get down to this extra episode of controversial theories or discoveries in paleontology. Now, in any kind of science actually does involve some controversy. And basically, controversy is all natural in science. And that's really part of science, basically, is that if there's basically a theory that's being played out, and like there's like a scientist or the public that just doesn't agree with it, and there's basically the big debates. Basically, there's big debates of whether or not the evidence actually supports one theory or the other, and that's basically how controversy kind of is. Is basically it's a big debate, and there's a lot of arguments between them, and it's basically kind of all that, you know. But I'll actually talk about certain types of controversies in paleontology. I'm not going to go I'm going to go through all of them. I'll actually give you some, and if you actually think that there's a controversial discovery or theory in paleontology that I haven't discussed yet, feel free to leave it in the comments section of this video, and feel free to actually let me know if there's any other kind of controversy that you think that should be out there. Anyway, let's actually get to the first controversy that I can talk about here. I'm probably gonna do 5 here. I'm probably gonna do 5, and I'll actually kind of let you guys actually think if there's another controversial theory in the comments. Anyway, the first controversial topic of paleontology is basically extinctions. We need to know when certain periods actually ended in terms of what kinds of extinctions actually happened. And this was a controversy that actually kind of started basically when Georges Cuvier, a French naturalist, basically, he actually came up with the theory of extinctions and came up with the word extinction. And you see, this was a new word actually being thrown out there during that time. And this was actually so new that people actually didn't understand what it was at that time. And so he gave a really good explanation. Extinction is basically animals that actually lived in the past and pretty much couldn't survive the changes in terms of environment, or otherwise something actually happened that actually caused this catastrophe, and pretty much they never actually went past a different kind of time to actually survive, and so they died out, and pretty much they never actually came back, and so they never actually were around the Earth past 50 million years. And you see, there were some controversies with certain extinctions. The biggest controversy in terms of extinction is the Ordovician extinction. We don't know what really caused this extinction. Could this be environmental factors? Could this actually be something that we have never even seen before in our lifetime? Like, there's the theory of the gamma ray burst theory, where basically gamma rays from a star that went supernova, it exploded, and pretty much gamma rays from the star actually hit the Earth's atmosphere. Parts of the Earth's atmosphere just blew away in space, and basically the Earth's atmosphere, you actually have basically an opening from the ozone layer, and where the sun's UV rays actually destroyed life in terms of certain areas, and then basically bacteria kind of takes over, and then pretty much certain animals couldn't survive and all that. But we still don't know. It's a controversial theory, and it's kind of being pointed out there. Another type of extinction is actually controversial is the Devonian. The Devonian is actually very controversial in terms of basically what could have happened. Was it a massive volcanic eruption? Could it actually have been maybe an asteroid or comet hit the Earth? or otherwise could there be environmental factors as well? Basically, like any kind of environmental situation that you can actually think of. But basically, one of the controversies that actually took place a lot more that was actually in the public was basically the extinction of the dinosaurs. The extinction of the dinosaurs was very controversial in terms of what really killed them off. What really killed them off? What happened around 66 or 65.5 million years ago? What really happened? And you see, there was actually like theories like maybe like it got too cold, it got too hot. There was, or otherwise like maybe like a meteor hit the Earth, or otherwise volcanic eruptions. But basically, I would say it's basically what the evidence actually says. It's basically a combination of basically the giant asteroid that hit the Earth and also volcanic eruptions. Because basically, when you have a massive meteor that actually hit the Earth, and pretty much it causes like huge earthquakes. It probably actually basically have some fractures into the ground, and pretty much volcanoes actually feed off of those earthquakes, and pretty much magma kind of comes up and starts shooting out, and also gases start dispersing through the atmosphere, and so that kind of happened and all that sort of stuff. Another controversy is basically Jack Horner actually proposes basically the Morphism Theory. Morphism Theory is is kind of like this. He proposes that certain dinosaur species that we actually know are probably one species that was actually just given a different name, is because we didn't know that these animals are actually the same species, because the species that has been found that is given this name is a juvenile of a species that was already found. And it changed through time as it got older into adulthood. It's because like either the spikes actually kind of reduced, or actually grew more spikes, or otherwise there was changes into the skull, like say it actually, like there was like it actually got holes on the frills, or otherwise maybe like the teeth changed, or in the length of the skull actually reduced, all that sorts of stuff. And you see, it's controversial into the fact that is basically some paleontologists kind of agree with this. It's basically like, it kind of makes sense. It's that like with the Pachycephalosaurus and Stygimoloch and Dracorex is basically this, that he believes that Dracorex and Stygimoloch are actually, like basically Dracorex is a juvenile, Stygimoloch is a subadult, and then Pachycephalosaurus is actually the actual adult dinosaur, and basically these are the same species. And there could be some truth into that, like say like with Dracorex, you kind of actually see like maybe as it gets older, the spikes actually kind of reduce, become lumps, and basically that's when the dome in the head starts to expand, and all that sorts of stuff. And it's kind of same thing with the Triceratops and Torosaurus. Is basically he believes that concerning that the juvenile Triceratops, their horns and frills change as they get older. Is basically like they'll start off as little bony stubs, and then pretty much the horns start going straight, but then they start curving backwards, and then pretty much as they get towards to adults, they start curving forward and start to become straight, and then sometimes be curved forward as well. And he also believes that the change in the frill actually, and there's changes in the frill, like basically like Triceratops horridus that we actually know probably was actually a subadult, and pretty much Torosaurus is actually an adult version of Triceratops, and so Torosaurus should actually be named Triceratops horridus and all that. And he also believes that sometimes with Nanotyrannus is probably a juvenile synonym of Tyrannosaurus rex. He believes that the teeth actually reduce, and also the teeth change as the juvenile starts growing and becomes more of an adult. But there's also some holes with this theory, though, too. Is with the Triceratops Torosaurus theory is basically this. I do not, and from what I've actually seen out of this is basically this. I just don't see how Triceratops would start losing bone in the frill, because it doesn't make sense. How do you reduce bone as you get older? That's actually one question I actually have for Horner. How do you lose bone in the frill? Because basically Torosaurus has got holes in the frill, so basically it probably had to be covered with skin in that part of the holes. And so that really actually has to come into play here, is how does that happen? And also with the Dracorex, Stygimoloch, and Pachycephalosaurus, how do you determine that these animals are actually juveniles? I mean, yeah, juveniles tend to have more spongy, more loose bones, and pretty much adults actually had pretty much have fused bones, and they're not so spongy, and so that could actually come into play there. And also another way is that how do you actually change the skull as you get older? Because basically drastic changes in certain animals, basically there's drastic changes in insects, there's drastic changes in amphibians, and some fishes. And so the question that I think is this: how does this happen as in terms of terrestrial vertebrates? And that's really how I actually kind of question this, is that birds really don't morph into something else, and also mammals don't change into something else. Reptiles don't change into something else. Say within 5 million years in the future, something or somebody discovers the fossil remains of a baby alligator, and then basically finds an adult version of an alligator, and then names the juvenile as a different species, just because they believe that the juvenile alligator is actually an adult version of probably a small crocodilian that lived around basically at this time. But basically there is a problem with that, and basically is that you can't name a species just because there's certain types of differences between adult, that basically some parts are actually the same as with an adult. Like it has the same amount of teeth, it actually has the same shape of a skull, it actually has the same bones, and all that sorts of stuff. And another way is this, is that how do you change the teeth? And that's really why I have a question basically with the Tyrannosaurus Rex theory of basically how can you tell it's a juvenile of changes of teeth? Basically, how does the teeth get thicker? That's really how I kind of actually think of that. But I mean, you can reduce teeth and all that, but you see, I just have a problem with that theory is because it just almost sounds like that. It's almost like saying like a cheetah is actually a juvenile version of a leopard. And you see, cheetahs and leopards almost look the same. It's just that one has a slender build and the other one is a little bit more, have a more robust build, in that kind of way. And I just don't see it. I just really don't see it. I just don't see how this theory could actually be really 100% accurate. So I have a lot of questions with that theory. Another controversial theory is basically what certain animals actually look like, and that's really hard. That's really hard. It's really hard to actually find out what they actually look like. That's really a point of emphasis. Because you see, when George Cuvier actually named marine reptile mosasaur, he actually claimed that this animal is very old and it's reptile. It has relatives like the monitor lizards, and so what actually happens is this: is that scientists tend to actually use modern animals to actually find ways to fit some of these prehistoric animals of what they look like. And so that was a big mistake. It was basically is that pretty much is you actually have like they looked at monitor lizards, they looked at iguanas, they looked at reptiles that they think are probably similar, and probably put them into other types of animals as well. Because also that was the same thing with Basilosaurus. They actually thought it was actually a marine reptile, but in fact it was actually a whale later on as years gone by. And that's kind of the theory, and that's kind of a problem, is that scientists have no clue what certain animals look like. We don't know what their color is. We don't know what their skin looks like. We don't know a lot. We don't really know a lot. I mean, that's really how that kind of goes. Another controversial topic is basically the geologic time scale. The geologic time scale has been very controversial in terms of religious folklore and scientists. And that was actually this is a huge deal. And basically, a lot of religious folklore that tend to look at the Bible, and they actually believe that the Earth is actually 50,000 years old. And what scientists actually say is that no, it's not really 50,000 years old. We have evidence to support that the Earth is actually 4.6 billion years old. And so religious folklore and scientists kind of clash over this. Is that which do you lean towards? And I tend to believe the scientists, just because you see I'm in a science major, and I actually believe that this is actually what the evidence actually says. But also with religious folklore, they tend to actually look at the evidence the wrong way. They actually tend to actually think that scientists are actually using the wrong way of dating. They actually believe that they use like certain types of chemicals to actually make the rocks look like it is like 4.6 billion years old, or 300 million years old, or 100 million years old, 50 million years old, 1 million years old. And so that was actually a problem. And also they believe that certain animals actually walked along with humans, but there's no evidence to support this. That's really a problem. There's some people out there that say that dinosaurs did walk along with humans, but we don't see that in the fossil record. There's some places that say they claim that they actually found dinosaur footprints along with humans, but basically what it is basically it's just a fake. It's just because somebody carved a human footprint along with the dinosaur track, and so that really kind of happens. But one controversy that I will talk about here is basically, I think is a top controversy, is which animals belong to which group. And that's really is because we need to find evidence to support this. Is that we need to find evidence of basically which animals belong to certain groups of certain family groups of animals. And that's really based on biology, and that's really based on how the theory of evolution kind of comes to play. And so, with the Nanotyrannus Tyrannosaurus Rex debate, is Nanotyrannus its own species, or is it a juvenile? That kind of thing. And so that's really a hard thing to actually kind of figure out. And also which cat belongs to which part of the cat family. And so that kind of way. Anyway, that's it for now. And tomorrow I'll actually be doing a special episode. I got a pterosaur I'll be talking about. And so if you got another animal that you actually want, prehistoric animal that you want me to talk about, feel free to email it to me at dinochris71@gmail.com. Otherwise, go on my Facebook page. I have links to a list of dinosaur names and mammal names and all that sorts of stuff. And you can actually look up the ones that I haven't done yet. And so feel free to do that. And also, you can still send me questions about dinosaurs or any other prehistoric life by emailing me at dinochris71@gmail.com, or let's go on my Facebook page, Prehistoric Facts of Dino Chris. Like the page, you can actually post your questions in the comment section on any Facebook post. Remember, keep your questions short and to the point. And also, you can follow me on Twitter at CSGRILL. That's my Twitter page. I post pretty cool stuff on there. And also, take care of the people around you. And also for younger people out there, make sure to listen to your parents, your teachers, and your guardians. So the best motivation you can have for good education. It's very important to have good education. With good education, get a good job in the future. All right, that's it for now, and I'll see you guys tomorrow.